Hello, my name's Jonathan Cromedy, and today we're going to be asking ourselves the question, how does AI work in a sensory standpoint? This report will go over the fundamentals behind the AI mechanics and how they're applicable to games, further increasing my understanding as a generalist games designer. Now, before we can answer this question, I feel like it's best to discuss what is artificial intelligence. Here's a definition I brought up from the Oxford Languages website, and while you read this, I'll explain my report's content. I will be making a stealth game AI which has the ability to both see and hear the environment around it, and make decisions based on what it hears and sees. To further better the understanding of AI, let's go through a few examples of early AI uses in games. Around this time, artificial intelligence was made to push the boundaries of already existing physical games, starting in the early 1950s. These games include checkers and Nim, but I will be talking about chess AI since I feel like it's a lot more interesting. This AI was self-learning, being able to learn from professional opponents. This would include certain moves they would make, being able to counteract strategies that the enemy is setting up, and being able to determine the value of the opponents and the AI's pieces, allowing the AI to make good to neutral trades with the opponent all the time. However, it took many years for the AI to get to the level of beating a reigning champion, until around 1989. Of course, if someone was playing a video game and the AI in said game was unbeatable, that would make the game boring, as no player would ever be able to beat any other levels of the game, making it pointless. Early arcade games would make primitive AI, however, would introduce different kinds of enemies for you to go up against, allowing the player to adapt playstyles. There are many early games like this, such as Space Invaders, Galaga, and Pac-Man. Pac-Man does this in an interesting way, as all four ghosts have different behaviors. The red ghost constantly chases the player. The orange ghost takes random directions, while the pink and blue ghost try to flank the player in the maze. This allows for gameplay that can lead to many different scenarios to play out, giving the game more replayability. Now, let's take a look at my pre-production and what I hope to achieve with this project. As you can see on the flowchart, my plans were to research areas that were related to the project, find my strengths and weaknesses in the sector, plan out my timetable, and then start production. And for my timeline, I have listed all the fundamental mechanics I will need to add to the project, and when to expect them. In the later weeks, I also list some things that I could possibly do if I had the time. With that all out the way, let's talk about the AI I've created. In order to make this AI, I had to learn Unreal's Behaviour Trees system, which is a must-use for anyone in industry using the Unreal Engine. This allows the AI to create various branches which lead to the AI doing certain tasks, based on the situation, breaking down decisions from left to right, encountering a success or failure depending on the branches. There are three key nodes that make a behavior tree. Selectors, which selects a branch underneath it depending on its priority. The further to the left the node is, the more priority it has. It can also choose based on variable values stored within Blackboard, which is linked to the behavior tree. Blackboard is an add-on to behavior trees where, from Blackboard, behavior trees can edit variables and change them accordingly. You can use this to determine what branches, selectors, and sequences should take below them. I mainly use this for checking enums and booleans, usually checking if the AI can see the player and what state the AI is currently in, which determines its behavior. A sequence is a node that calls every node it's connected to, left to right. This is often used to call multiple tasks or looped events at once. For instance, I use this in the guard's search phase, when it loses sight of the player and looks around. It looks in random directions 3 times before giving up. Although this is not a node, decorators are attached to sequences and selectors. These decorators tell the game the certain variables necessary to be able to activate this node. When the criteria is met, it will grant the previous node access to a path through this node, with a priority system of leftmost branches still being in effect. For example, I use this decorator here to check if the AI's is investigating boolean is true. If it is, it opens the branch, allowing the AI to investigate a sound that has been heard. Finally, a task is a mini blueprint of sorts that can be called by a selector or sequence if they are connected to the one that is currently being called. These are the functions that determine whether certain values of the AI should be changed and what to change them to. For example, when the AI patrols on its patrol path, I use multiple tasks which are selected by the selector based on variables on the blackboard. The bottom screenshot shows the loop path task. It checks if that particular guard's path loops, and if it doesn't, it fails, and instead uses the increment path index and decrement path index. This is because instead of the guards looping, they will reach the end of their path point, then go backwards. As I mentioned before, these AI have different behaviors. These 4 behaviors are listed in order of priority. These behaviors are chasing, investigation, searching, and patrolling. The AI switches between these behaviors based on what it sees and hears. The screenshot that you are seeing is the entire behavior tree of the AI. It is a lot to take in, so I'll break down the basic functions of these phases the AI has. It will only begin its chasing phase when the AI sees the player. This will make the AI run at the player at 550 units of speed, which is the fastest the AI can travel. When the AI gets within 150 units of range, it will attempt to attack the player with a melee attack. Its investigation phase triggers when it hears a noise that it can't hear. It will walk slightly faster than its regular walk speed at 350 units of speed. It will rotate to the noise, wait a bit, and then move to the source of the sound. When the AI finishes looking at the source of the sound, it will go back to its patrol path when it doesn't see the player. Its searching phase happens when it loses sight of the player during the chasing phase. Upon losing the player, the AI will look around the area around the last place the AI saw you. After looking at a different location 3 times, it will go back to its patrol path. Finally, the patrol phase is the default state the AI goes to when none of the other phases are in effect. It will follow its patrol path at its slowest speed, 200 units. Even the player can sneak slightly faster than this speed. For the AI's perception, it has 3 main properties that allow it to sense things. It has peripheral vision, max viewing range, and a hearing range. Its peripheral vision is the green cone which you see here. If any humanoid goes in this cone, and they have no terrain to cover them, the AI will see them and chase the player, like so.
You're not supposed to be here.
The max viewing range is how far the AI can see from. This is shown by the green circle around the AI. Finally, its hearing range is the yellow circle around the AI. Now you may think this is large, however, this is just the area of which the AI can hear sounds from. Sounds have a value that determine the distance that they can be heard from. Here's an example of it hearing a sound.
Someone there? Wonder what's for dinner.
Although you may think these senses on their own are easy to deal with, the player also makes noise when they walk. The faster you run, the more noise you make. This allows the AI to hear sounds through walls and know where you're making the noise from if you're not careful enough. To update its perception, I had to use its AI controller. Some problems I had when implementing the AI's sight was, when it saw another guard, the AI would think that it had seen the player, and run straight for the player's location, even through walls. I fixed this by making sure the player could be the only one who triggers the AI senses by adding a cast to them, thus making it only able to chase the player when the player was seen. I also had some issues with the AI's hearing. Because I didn't make a priority system, the AI would want to go after any sound it could hear. You could even throw a rock somewhere while the AI would be chasing you, and it would want to investigate the noise instead. To combat this, I added a priority system in the AI's senses. It would check if the AI could see the player. If this was false and it heard a rock, it would go after that sound. Otherwise, it would continue to chase the player. Now, you probably realize that the AI actually has its own voice lines. In total, there are 17 different voice lines that can play, which were made by me. There are 5 voice lines that can play at random when the AI sees the player, 5 voice lines that play in random when it hears a sound, and 7 voice lines that play when the AI does not see the player by either searching or investigating. In conclusion, I have replicated the main fundamentals of making a stealth game AI by giving it the required sensors and actions that they would normally take. I have also been able to show some aspects of level design by creating my own map and making design decisions based on them, such as giving the player dead zones where the AI can't see them unless the player is spotted by them beforehand, and made parts of the game where you can utilize certain mechanics. I now have a good grasp of how behavior trees work in the Unreal Engine, and now have a better understanding of how AI functions in games, which can be applicable for multiple genres in the media. Although the AI isn't perfect, and there were more mechanics I wanted to do, such as decreasing the AI's vision depending on how dark the area the player was standing in was, I am happy with the project and the progress I have made in this module. These are the useful references I have used when researching about AI in this module. Thank you for your time.